Okay, everyone, welcome to today's video. We're working with the regression analysis. We're starting today with that. It's the fourth chapter. We're going to be looking at scatterplots today. As we learned, association with variables is the majority of what we're working with in statistics. And when we're working with two variables, we can try to see if there are some associations that we can make between looking at two different sets of variables. How tall somebody is with how good of a basketball player they are, things like that. From what we're going to do, we're going to be able to then make some, from our observations, to maybe predict what's going to happen as we're going forward. When we work with one variable, we were more concerned about how often a category happened rather than what relationship it had to the rest of the data set. We use histograms and dot plots to kind of visualize what the data and what the distributions would look like based on that information. Just so we could kind of get an idea of how often something happened, where it was going to be, what we were looking at. Two-way variables, with two variables now, what we're going to be looking at, especially when they're numerical values, is how are they related, what type of relationship do they have, and again, we're going to start looking at graphs for that. We're going to start with scatterplots. So when we're visualizing scatterplots, using the scatterplot only works when we're looking at variables that are both quantitative and can be represented by a point on a coordinate grid. So you're going to have two variables, they're each going to have a number, and that group, that observation, is going to be the point we're going to graph on the scatterplot. So here's an example. We talk about at what age men and women first marry in the United States. We did a study on the 50 states, and we took out the median. We found the median age that both men and women marry in each country, and we plotted the 50 states and the Washington, D.C. on a scatter plot, which looks like this on the next slide. So the dots are showing us the typical age where men and women marry in each state. We know from what we've been told that the bottom 2 points in the left corner down near the origin are the points for both Utah and Idaho, and they represent typically a 23-year-old woman and a 25-year-old man. That's about what typically happens in Idaho and Utah, that's when people marry. We also have the point Washington, D.C., which is the upper right-hand corner. And again, there we're looking at probably 30, 31 is about the time that both men and women marry. One thing we want you to notice is that the points don't start at 0, 0 like they do on the coordinate grid that you had in like geometry and algebra when we were plotting lines. We can actually start them at a number because we're focusing on the data. We're trying to kind of zoom in on where that data is. So rather than having a whole scatter plot with blank information from 0 to 23 and 0 to 25 for the men and the women, we're going to start where we're at 23 and 25 already, and now we have our data filling in that way. It just makes it a little easier, a little more concise for us to see the data in our points. So when we're looking at that, we're going to be able to start making some observations from the points as we're going through. So again, we're looking at the median age for women, and we're going to be, what is the median age? So when a woman's 25, we see the bottom of the chart, we go across to 25, we see what the woman's age is. What's the typical age for a man to marry at that point? What we see there is we kind of go up and see that it's probably somewhere between 26 and 27 years old is where a man is. So like whatever we're expecting that to be when we're looking at a 25-year-old woman, we're expecting the man to be 25, 26 or 27 years old. Does that make sense? The next thing, so it's probably, 27 is about where I would be. So the next question was, again, we were told Washington, D.C. was way up on the top right-hand part of the screen. So again, what are the ages where a man and a woman would marry in Washington, D.C.? Again, we're looking at, we kind of go over to the woman. It's pretty close to 30. The man, it's somewhere between 30 and 31. So I'm going to lean toward the other side and say that the man is about 30. So in Washington, D.C., the typical marriage ages are for women 30, for men it's 31. That's what we're getting from this data on our data plot, our scatter plot for the marriage ages of the typical marrying age of different states in the United States. Another thing that we're looking at when we're trying to look at the observations of the different dots is to kind of get more in depth into the examination. We're going to do this by looking at the trend, the strength, and the shape of the plot. The characteristics are similar to the characteristics we looked at in the last couple of chapters with the histograms, where we were worried about the different things we were worried about in that. Here we're worried about, so like when we're looking at the trend, that's similar to the center of the histogram. So what's the typical value of a histogram was the center or our mean or our median. Here we're looking at the trend, so what's the data doing? The strength is what we're looking for. That was similar to the spread of the data, the range of our data, the variability of our data in our histograms. So in the histogram, the wider the spread, the more data, the more variance in the data. Same thing here in our dot plot, that the more variance, the more spread out the dots are on our scatter plot, the more variance there is with our data there. And then the shape, again, we're talking about shape. It's like we're just looking at the shape of our graph, just like in the histogram, we looked at the shape of the histogram. Was it skewed? Was it not skewed? Here we're kind of see, is everything bunched up together? Is things spread out really wide apart? What are those different meanings? What does that have for meaning for what we're looking to do on our plots that way? So we'll be able to analyze the shapes of the scatter plots to help us with the data analysis as we move forward. So now we're going to kind of look at recognizing our trends. And what is the trend of an association? What are we talking about when we talk about a trend? The trend is the general tendency of the scatter plot as you scan from left to right. So just like you read a book, we're always going to be reading our scatter plots from the left side of the graph to the right side of the graph. What's happening with that? Are they going up? Are they going down? Is everything spread out? Is everything grouped together? What are we doing? Usually the trends are either increasing and uphill or decreasing and downhill, but other possibilities are going to exist. The increasing trend, they're called positive associations or positive trends, and the decreasing trends are called negative associations or negative trends. Again, we're not able to specifically say, yeah, based on this value, that's a number. It's not a concrete prediction or a concrete observation. We're talking more associations. So we can expect this to happen based on what we know from our data. So again, we're looking at our plot for the marriage ages and like what type of trend do we see? What are you looking at when we read from left to right? What's happening? So again, on this trend, we see that the trend appears to be a strong linear trend, positive trend. Again, positive, negative in this instance might not be as obvious as we want to say, because like as the ages of people go up, the trend is going up, but we don't really know, is that a good or a bad, is that a positive or a negative thing for marriage ages? Who knows? So what we're talking about is the trend of, as the line of our graph or the line of our data, as we're looking at our scatter plot goes, is it moving up from left to right? Then it's positive. If it's moving down from left to right, then that's negative. And again, we'll have to decide later on what the data is telling us. Is that a positive or negative? Is that good or bad? Positive or negative with relation to the data. So here's a couple more examples from trends, try to make sense of that. If we look at this data, it's a scatter plot of the average age, or the average number of miles driven for the age of a car. Does this trend make sense to us as we look at this? So what's the trend of the scatter plot? Figure out, is it positive or negative, and does it make sense? So as we look at it, yes, it's a positive trend. We see that the data is generally increasing from the left to the right. We would expect that. It makes sense because as cars get older, we're expecting the data to have more data. Like my car, the first car that I gave my son when he got his license and I bought my new car, it was a 2004 car that I had had for 14 years. I gave it to him. It had 250,000 miles on it. So it's high of what you would expect, but you would expect it to be a lot of mileage, and then you can kind of be surprised that it was 250,000 miles when he got the car. Another one we have here is a scatter plot of the total birth rate of women as compared to the literacy rates of the countries that they live in. So The lower literacy rates, the less people, a percentage of population that read is on the left, the higher the percentage of people that read is on the right. And then the birth rates is like, does this make sense? Would we expect to see that type of data as we're going through? What's our trend look like? Is it positive or negative? And then does it make any sense? And again, we're going to call this a negative trend. It makes sense because typically low literacy rates in countries, they're typically poorer countries that may have a more agricultural background, a developing country, so that they don't have the education, and they typically just have more kids than the more developed countries like the United States and most of Europe, where the literacy rates are much higher, where a lot more people can read. So there's more education, so they kind of start limiting the number of children they have because there's just a general trend, and that's what the general trend line. We go to trend lines. That's typically what people do is they get more developed countries tend to have less children per woman per family than the poorer developing countries. And then sometimes where our scatter plots aren't going to show any trend at all. Here we have a scatter plot of the speed someone runs a marathon related to their age. And I know it doesn't really make any sense that there's this data actually still makes sense. It's like there's no real trend here. So what can we conclude from this? And what you would conclude in this plot where there's no real rhyme or reason to the speeds of people, like a 70-year-old person can run a marathon, and there's someone in that chart that are almost 70 that ran the marathon in a little over 4 hours, where there's a 20-year-old or a 30-year-old that ran it in 6. It's not an age thing, so we're saying age isn't really associated with the finishing times of the marathons. I know my age, I'm 50, there's no way I would even be able to finish running a marathon, so it does nothing to do with age. It's just the training and the overall fitness we're looking at, so this is what we would expect for our data. So then we're going to talk about the strength of the association. We talked about that's what we're looking at. It's like, and we're able to see the estimates of strength of a scatter plot based on the amount of spread there is on a vertical association with our data. So the weaker associations are represented by plots that have more vertical spread throughout the whole of the data scatter plot. A stronger association, the dots are going to be more closely together, placed more closely together. They may even be bunches and groups of big blobs of data that you really can't tell that there's more than one dot there. So that's what you'll see. It's going to be more or less vertical variation for the stronger plots. Again, we're going to see examples as we go forward. So here are our two plots. They're associations based on height and weight height and waist size to weight. The graph on the left is height versus weight. The graph on the right is waist size toward weight. And they both show we both see that they're both positive trends. So the taller somebody is, the more weight, the more they weigh. The bigger somebody's waist size is, the more that they're going to weigh. It's what we'd expect to see just based on what we know about the human body and stuff like that. But what we're looking at to really see is that there is, we're trying to figure out which has the stronger association, which on the next slide is the question that we're asking. Like looking at this data, which shows a stronger association? Which one would we say is a stronger association? And then even if you want to get into it is why. Why is it a stronger association? So when we look at it, the graph on the left, the height to our weight, it's not as strong. It's kind of spread out a little more. If you look at at about the 70-inch in height, we have weights about as low as about 130 pounds. And even here, I've used 65 inches on our chart, on our description. It's like at 65 pounds, the weight ranges from like 120 up to almost 240 pounds, depending on the person. So if we were trying to predict weight based on just height, we're going to be way off potentially for, depending on who we're talking about, what we're looking at. I mean, just knowing that it's a 65 inch tall person, we don't know if it's going to be male or female, and even that's going to cause a change in our scatter data. When we look at the waist size, though, everything tightens up considerably, and now we can have a pretty good estimation of somebody with a 30-inch waist is going to weigh between this amount of this many pounds, just because that's what typically ends up being. Like skinny people weigh less, have skinnier waist sizes. So now it's kind of tightens things up, and we're able to give a much better prediction based on the data that we see. Does that make sense? Okay, so then if we're going to ask somebody's weight, which question are we going to ask? We're going to ask them, how tall are you, or what's your waist size? Obviously, we're going to ask what's your waist size. So the last thing we're going to talk about, I think, is identifying the shape. Again, we're just looking at our dot plots and our scatter plots. Typically, the trends are all linear. We want to have linear. As we're going through this unit and the chapters of our book, we're pretty much just going to be dealing with linear regression analysis, because the other ones get way too difficult, and it's just not something that we're going to cover right now. So our linear trends, everything always increases or decreases at the same rate. Think back to algebra when we learned about the slope of a line and linear equations and that. That's what we're talking about when we're talking linear. It's the same concept. So that as we look at our plots, if we kind of went back to the waist size plot, you're looking at everything's trending up from left to right. It's trending up, and things are kind of pretty closely related to a certain line in the middle of it, that we could probably draw a pretty good line right through the middle of our data and would have a straight line that would estimate our data, which is what we're going to be getting to. A scatter plot of a linear trend will always kind of look like a football. It's going to be kind of bunched up in the middle. It may be a little flatter, a little puffier on the ends, things like that. But overall, you're going to see some type of grouping of data that in most cases is going to be reminiscent of like a football shape, and what we would kind of see as all the data gets grouped in the middle. So again, we kind of like, it's not the best, but you kind of see how it's, if you look at the lower portion of the chart here, of our chart here of the searches for zombies and vampires on Google, like if we just kind of look up to one on the vampire line, it's like the data kind of starts off really tight, kind of widens out as we get lower, and then kind of groups back down into the middle. So it's what we're looking at. That's kind of how the shape we'll see. You'll see as we go through all these, there'll be lots of examples with that'll look like footballs. And again, this is a trend line showing that it's a positive linear trend, though I actually put a trend line in there showing here's what we're looking at if we were looking at the data. There is other data that's not linear. It's more curved. It's more like a geometric exponential growth kind of thing that we learned in math, that we're not going to look at that at all. I just wanted to show you that there are trends that are nonlinear, that are a little harder, a lot more harder to analyze. But again, if you did a scatter plot of data and you kind of got this type of scatter plot, you could still make an observation of, oh, it's a pretty positive growth, everything's tightly related, it's pretty strong because everything's really closely associated with our line in there. But then it's a matter of, we're just not going to go any further than just kind of describing the scatter plot. So as we're looking at scatter plots, like we kind of had back with our histograms and analyzing our data that way, we're going to need to describe what we're seeing from our graph to move forward in what we're doing in our analysis. So as you're looking at the scatter plot, we're going to be looking at and describing the trend, the shape, and the strength of your data, your scatter plot. It's not always going to be in that order. You might kind of move it up, change it around here and there, but they should always be explained and describe what they look like, and it should always kind of be brought into the context of what the data. We talked about statistics as the numbers in context, and that's again where we are. What does the trend, the shape, and the strength of our data look like in relation to what we're trying to examine? You should also mention any observations that kind of look like outliers. Is there a value that's way off the middle of the data point that we just don't know where that is? Is there something way high that we, again, just doesn't look like it fits into the data? Mention that and say what you think it might be. Is it an outlier? Is it possibly a mistaken observation? Something in there is causing a problem with it that we need to know what it is. Excuse me. So as an example, we go back to the scatter plot of the miles based on the age of the cars that we had. And we're asked to describe the scatter plot. excuse me again. So take a few minutes and kind of piece together and put together what you would think a good description of this scatter plot would be. So as we look at it, when we review the scatter plot, a good description is going to be in reviewing the scatter plot of miles driven for cars of different ages. We see a strong linear positive trend showing that the older a car is, the more miles we would expect the car to be driven. That's what we expect. It's what we're going to tell them. It's what we're going to say when we're doing it. There's a minimal amount of spread on cars less than 10 years old because that's where stuff's more tightly packed together. But as the cars get older, the spread kind of widens, and now it gets to be a point of, and now you kind of look at why is it so wide? Well, you'd have to like dig deeper into those numbers. But then we also have this one observation of a car that's about 6 years old that there's almost 250,000 miles on it. That's a lot of driving, and you'd want to mention that as you were describing the data. Because, hey, we got this one car that might be throwing off everything we're looking at. So on the next slide, there's an example I want you guys to take a look at, kind of write up what you think, and you'll be able to enter your notes as you've been watching the slides kind of shut off. It's like enter your description there, and from that, we'll go forward and we'll see what you have. Okay, I didn't put on the slide, I just wanted to kind of talk about this one. What we have is, if you kind of go back, it's the heights and weights of students in a statistics class. And again, we kind of look at it and we have most of the data is kind of centered around 60 feet, 60 inches tall. It goes from 100 pounds kind of up to 280, depending on how tall the people are. But then we get this one little point way down on the left that just doesn't look right at all. It's somebody that looks like they're about 15 inches tall and they weigh close to 100 pounds. I'm like, I don't know about you, but that's an awfully big baby. So that's something that you would want to mention in your data too. Is like this, we have a potential outlier. We might even have a mistaken entry in the data that we're looking at, in that this data, this point just doesn't make sense to what we're looking at. It's a 100-pound person that's only 15 inches tall. Doesn't make sense. So we'd probably want to take a look at that one and then even eliminate that data point or find out what it should have been to try to make our data look a little bit better. And then again, once you do that, your scatter plot's going to look a lot better because now you don't have all this blank space in the middle between 20 and 60 inches tall. So, hope that makes sense. Scatter plots, again, it's just kind of looking at the data, looking at the graphs. What is the data trying to tell us? What can we pull from that information to move forward in what we're looking at doing as we kind of get further into our trend analysis and our regression analysis of what we're looking to do. So, hope everybody understood this. You can watch it again if you need to. And I will see everybody next time.